Dear students, Assalamu alaikum. It's week number 6 and also we are having chapter number 6. This week is from 11th May to 15th May and we will discuss the chapter number 6, which is about the work and energy. And the content of this chapter are the work, energy, kinetic energy, potential energy, forms of energy, interconversion of energy. These are the content of this week number 6 and I will explain these topics one by one in the coming slides. And the objectives of this lesson are to define work and energy, answer the short questions on work and energy. These short question answer will be given in the assignment and students will be able to explain interconversion of energy. First of all, the work. Students, the work, you all know that it is a scalar quantity and the work is said to be done when a force acts on a body and that body moves in the direction of the force. The last sentence is very important, that the body moves in the direction of the force. I will explain this in detail. You know that work refers to performing some task or job. In science, work has precise meaning. For example, a man carrying a load is doing a work, but he is not doing work if he is not moving while keeping the load on his head. It's very important. When person is keeping the load on his head, he is moving forward, but force is vertical. So the angle between the displacement and the force is 90 degree. The work done is 0. I will explain in the next slide in detail. Scientifically, work is done only when an effort or force moves an object. When work is done, energy is used. So work and energy are related to each other. The concept of energy is an important concept in physics. It helps us to identify the changes that occur when work is done. We will also discuss the concept of power as well, but it will be in the next lecture. Now we come to the work. Again, in physics, work is said to be done when a force acts on a body and the body moves in the direction of the applied force. It is scalar quantity and work is the product of the force and the displacement, and you know that symbol for force is capital F and for displacement is capital S. So W is equal to F into S. Hence, work depends upon two things. Number one, the force, and number two, the displacement of the body in the direction of the force. Now, it is not usual that force does not always act in the direction of the motion of the body. It is our common observation that sometimes the force has some angle with the horizontal. It means that force is having an angle with the displacement. In this case, the work done is equal to F cos theta into S. I am talking about F cos theta. F cos theta is the component of the force, that is the horizontal component of the force, which is in the direction of the displacement. And you know that in chapter number 4 we studied that Fy mean vertical component is equal to F sin theta and horizontal component is equal to F cos theta. Here we are using horizontal component as body is moving horizontally, so W is equal to F cos theta into S or Fs cos theta. Hence work depends upon three things. Number one, force. Number two, displacement. And number three, the angle between the force and the displacement. Now, in previous slide, I said about when the person is moving the load on his head, keeping the load on his head, he is not doing any work. Here I will explain that why he is not doing the work. When a person moving some load on his head, or a student moving his bag, carrying his bag on his shoulder from school gate to the classroom, he is not doing any work because he is applying the force in upward direction on the bag, and bag is moving in the horizontal direction. So the angle between the applied force and the displacement is 90 degree. And students, you know that if theta is 90 degree, then cos 90 degree is equal to 0. You can verify this by using your calculator, that cos 90 degree is equal to 0. If cos theta 0, then the whole work done will be 0. Hence, in science, a laborer who is carrying a heavy cement bags from morning till noon, he has done no work because he is carrying the cement bags on his shoulder, on his head, or on his head. The displacement of the cement bags is horizontal and the force on them is vertical, so angle between them is 90. Although this person has used lot of energy, he might be tired, but physics says he has done no work. SI unit of the work is joule, and we can define 1 joule work. The amount of work done is 1 joule when a force of 1 Newton displaces a body through 1 meter in the direction of the force. And our next topic, it is energy. Students, energy is an important and fundamental concept in science. It links almost all the natural phenomena. When we say that a body has energy, we mean that it has the ability to do work. Water running down the stream has the ability to do work, so it possesses energy. The energy of running water can be used to run water mills or water turbines, which can be used to generate electricity. And we know that energy exists in various forms, such as mechanical energy, heat energy, light energy, sound energy, electrical energy, chemical energy, and nuclear energy. I will discuss these all one by one in the next slide. But you should keep in mind that energy can be transformed from one form to another. So, coming to the energy, a body possesses energy if it is capable to do work. And mechanical energy has two types. Number one is kinetic energy, and number two is potential energy. And I will discuss these both types one by one in the next slide. Number one in this slide is kinetic energy. And you know, students, moving air is called wind. Moving air is called wind. We can use wind energy for doing various things. It drives windmills and pushes sailing boats. Similarly, moving water in a river can carry wooden logs through large distances and can also be used to drive turbines for generating electricity. So, a moving body has kinetic energy because it can do work due to its motion. The body stops moving as soon as all its kinetic energy is used up. Hence, we can define kinetic energy. The energy possessed by a body due to its motion is called kinetic energy. And derivation of this kinetic energy, I have written the formula in front of you. K is equal to half mv square. Its whole derivation is on the next slide. Now students, In this slide, consider a body of mass m moving with velocity v. The body stops after moving through some distance s due to some opposing force such as force of friction acting on it. The body possesses kinetic energy and is capable to work against opposing force F until all of its kinetic energy is used up. And students, when all of its kinetic energy is used up, it will stop. It means that its final velocity will be zero. But kinetic energy of the body will be equal to work done by it due to motion, or Ke of the body will be the work done against the applied force, opposing force. So Ke is equal to F into S. F means the opposing force and S the distance for which this opposing force is applied. And we know that body initially was Vi is equal to V, and final velocity was 0 because as body has stopped due to the opposing force, its final velocity is 0. And we know that, students, from second law of Newton's second law of motion, F is equal to ma. Here F is the net force. Now A is equal to F over m. You can see that minus sign. Here minus sign is used because the body is experiencing deceleration, mean body is slowing down. When we use opposing force, the speed of the body slows down, mean it becomes 0. So acceleration will be negative acceleration. Hence that's why we have used A is equal to minus F over m. So from third equation of motion, 2as is equal to vf square minus vi square. Now put the value of A, which is equal to minus F over m, minus 2f over m s is equal to 0 minus v square. Hence, on the left side, m is being divided, and when it will move to the right of the equation, it will be multiplied with the v square, and 2 which is being multiplied on the left side, it will be divided on the right side. And on both sides, left or right, both sides we are having negative sign which will be cancelled out each other, and fs on left side will be equal to half mv square. So from equation 6.3 on the top and this equation from 6.4, Ke is equal to half mv square, because we said in the very beginning that Ke is equal to Fs, mean K is equal to the work done by the opposing force. Hence K is equal to half mv square, which is the desired formula which I told you in the previous slide. We can use this formula to find the kinetic energy of the moving body. Now students, our third topic is potential energy. And now you know that often a body has the ability to do work although it is at rest. For example, an apple on a tree is capable to do work as it falls. So it possesses energy due to its position. And a brick which is placed on the top of the roof, when it falls down, it can do some work, it can cause a damage, so it has energy. The kind of energy which body possesses due to its position is called potential energy. The brick I told you has potential energy. Apple on the tree has a potential energy. The hammer you used has a potential energy. So to define the potential energy, the energy possessed by a body due to its position is known as its potential energy. But students, keep in mind, we are only concerned in this chapter only with the gravitational potential energy, mean the energy of the body due to its position from the surface of earth. And also energy in the stored water which is stored at the height, it has a potential energy due to its height. A hammer raised up to some height has the ability to do work because it possesses potential energy. A stretched bow has potential energy due to its stretched position. It is called elastic potential energy. When released, the stored energy of the bow pushes the arrow out of it. The energy present in the stretched bow is called elastic potential energy. The potential energy possessed by the hammer, I told before, is due to its height. And energy present in the body due to its height is called gravitational potential energy. For the derivation, I have given the formula potential energy is equal to mgh. Keep in mind it's the formula for gravitational potential energy. Students, suppose that a body of mass m is raised up through a height h from the ground. The body will acquire potential energy equal to the work done in lifting it to height h. We have done the work to lift that object, and the work done is equal to the force we have applied on the body, that is equal to the weight of the body. If we want to lift somebody upward, we have to use force, and this force at least must be equal to the weight of the body. And here again we know that work done is equal to F into S. Here S is equal to the height. So potential energy is equal to F into H. And we know that I have told you that here force is equal to the weight of the body. Hence PE is equal to W into H, and we know that W is equal to mg. Now put the value of this mg in the place of W, we get PE is equal to mgh. This is the required formula for the potential energy or the gravitational potential energy. Keep in mind that this h is the height of the object from the surface of the earth. Now our next topic is forms of energy. Students, we are having 7 forms of energy, and these are mechanical energy, heat energy, electrical energy, sound energy, light, chemical, and nuclear energy. I have discussed these earlier as well, but I will explain them one by one as well. Mechanical energy, the energy possessed by a body both due to its motion or position, is called mechanical energy. Students, remember that in the 2 slides prior I told you that mechanical energy has 2 types, kinetic energy and potential energy. So mechanical energy is of 2 types. It is due to its motion or position. Water running down a stream, wind, a moving car, a lifted hammer, a stretched bow, a catapult, or a compressed spring. They all possess mechanical energy. Number 2 is heat energy. Heat is a form of energy given out by hot bodies. Large amount of heat is obtained by burning fuel, and heat is also produced when motion is opposed by frictional force. The foods we take provide us heat energy, and sun is the major source of heat energy. And number 3, electrical energy. Students, electricity is one of the widely used form of energy. In our homes we use electricity. Electrical energy can be supplied easily to any desired place through wires. We get electrical energy from batteries and electric generators. These electrical generators are run by hydropower, thermal, or nuclear power. Hydropower means the energy by the water stored at the height in the dams. Next, number 4 is the sound energy. When you knock at the door, the sound is produced. So sound is a form of energy. It is produced when a body vibrates, such as vibrating diaphragm of a drum, vibrating strings of a sitar, and vibrating air column of wind instruments such as flute, pipe, etc. And next is the light energy. Students, it is an important form of energy, and plants produce food in presence of light. We also need light to see things. We get light from candles, electric bulbs, fluorescent tubes, and also by burning fuel. However, most of the light comes from the sun. And number 6 is the chemical energy. Students, Chemical energy is present in our food. We take in food and that food contains a chemical energy. The fuels, they are also having chemical energy. We get other forms of energy from these substances during chemical reactions. The burning of wood, coal or natural gas in air is a chemical reaction which releases energy as heat and light. Electrical energy is obtained from electric cells and batteries as a result of chemical reaction. So animals get heat and muscular energy from the food they eat. And the last type is nuclear energy. Students, nuclear energy is the energy released in the form of nuclear radiation in addition to the heat and the light during nuclear reactions such as fission and fusion reactions. Students, fission and fusion not in a syllabus, but I will just give you an overview that fission is the process in which a heavy nucleus breaks into two or more lighter nuclei. This process releases a lot of energy, and fusion is the reverse process, and it two or more lighter nuclei join together, combine together to form a heavier nucleus. This process gives out the heat energy. Fusion takes place in the sun. Heat energy released in a nuclear reactor is converted into electrical energy. The energy coming from the sun for the last billion of years is the result of nuclear reactions taking place on the sun. And last topic of this week is interconversion of energy. Students, keep in mind energy can never be destroyed, but it can be converted into other forms. For example, if you rub your hands together quickly, you will feel them warm. You have used your muscular energy in rubbing hands. As a result, heat is produced. In the process of rubbing hands, mechanical energy is converted into heat energy. So, I have given this natural phenomena in front of you in the form of a photograph. A natural process, for example, rain, it is a process of interconversion of energy. The sun heat causes the evaporation of the water in the lakes, rivers or oceans, and this water evaporates and forms the clouds, and these clouds cause the rain again towards the earth. So heat energy causes evaporation, that causes the potential energy of the water vapors to form the clouds, and again those water droplets came to the earth in the form of the rain. So here in the second photograph you can see a cyclist. The cyclist, when he is on the smooth horizontal ground at the bottom of the hill and he is trying to climb the hill, he has in the beginning all the kinetic energy, and when he reaches the top of the hill he has the potential energy, and when he again comes down from the top of the hill to the level ground, his potential energy is being converted into kinetic energy. So students, these the energy can be transferred from one form to another form. Energy can never be destroyed. And now I will give you the recap of the whole lesson. Again, we study the work being scalar quantity, and it is the product of the force and the displacement F into S. And when force and the displacement are not in the same direction, then work formula is equal to Fs cos theta, where theta is the angle between the force and the displacement. Next was the energy and mechanical energy. Mechanical energy has two types, kinetic and potential, and kinetic energy is the energy possessed by body due to its motion, and its formula is K is half mv square. Potential energy, energy possessed by a body due to its position is known as potential energy, and formula for gravitational potential energy is equal to mgh. And the next were the forms of energy, and these forms were mechanical energy, heat energy, electrical energy, sound energy, light energy, chemical energy, and nuclear energy. And the last topic was interconversion of energy, in which we discussed that energy can be converted from one form to another, but it cannot be destroyed. So students, this was the uh, week number 6, the topic work energy. Hopefully it will be useful for you. Okay beta students, Allah Hafiz.